Okay, so let's talk about finding some of these angles in a regular polygon. So overall, there's really going to be two angles that I care about the most. The one will be the central angle, and then the other will be actually two angles that are created within the triangle that's created by two radii and a side. So let me go ahead and find my center here. So let's say that's the center of my polygon. So I can draw in some of these radii. And so what I'm going to start to realize is how many central angles that I have here. So in this case, I'm talking about a regular octagon. And so how many central angles am I going to have? Well, the number of central angles is obviously just going to be equal to the number of sides. And since all these will be congruent to each other, it's easy enough to find the measure here of this angle. Because if I add up all these central angles, I should get 360 degrees. And so if I want to find just one of them, I just need to divide it by the number of sides, which in this case is 8. Okay. And so what I get here for the central angle is that it's 45 degrees. So then, if I want to find one of these two angles here, number one, this is an isosceles triangle, so I could just subtract from 180, although it's going to be very common for us to set up this right triangle. So maybe there's another angle that I care about too in here, and that would be this angle, which is just obviously half that measure. So in this case, this would be, let's see, maybe draw an arrow. This would be 22.5 degrees. And then since this is a right triangle, this is my apothem here. What I'm going to get for this last angle is just, well, 90 minus 22.5, which is roughly 67.5 degrees. So this all just stems from the fact that, how many central angles do I have in my polygon, and the answer is, well, it's equal to the number of sides. So let's go ahead and try another one out. Here's a pentagon that I have. Here's a regular pentagon. So let's go ahead and find some of these angle measures. So let's start with our central angle here that's marked. So I've got angle BFA. So the measure of angle BFA will be equal to, well, so I've got a pentagon here, so there's 5 sides, which means that I have 5 central angles. They'll all add to be 360 degrees, so the measure of angle BFA will just be 360 divided by 5, which will be equal to 72 degrees, which means then that if I want to find the measure of angle GFA, well, that will just be half of that angle, 36 degrees. And so last but not least, if I want to find this measure in here, the measure of angle GAF, which is the same as the measure of angle GBF, I just need to subtract that from 90. So the measure of angle GAF will be equal to, well, 90 minus 36, which would be about 54 degrees, give or take. Okay, so that's how I find the different angle measures in a regular polygon. I'm going to use that to my advantage here in a little bit to find some of these segment lengths, of course, using something that we haven't touched in a while, but that's crucially important to finding the areas of regular polygons, and that would be trig. And we'll talk about that one in the next video.